Hello there. Right, today we want to continue with our discussion on isometric drawing. It's a revision paper from 2016. Like I said, we are going to focus on past exam paper so that we relate our experiences to the real exam situation. So we want to look at isometrics. We'll alternate between paper 1 and paper 2. Right, but we are going to reserve question 4 for our Saturday lessons when we have got more time. Like I said, it's isometric drawing. It's question number 3, paper 2, revision exercise, past exam paper, November 2016. We're still looking at approaches and application. As always, I hear and I forget, I see and I remember, I do and understand. The focus is on doing something in order for you to understand. Let's enjoy today's lesson and all the best. Right, this is what we have today. It's isometric drawing. Let me just take this one down. Right, isometric drawing. Given information, the front view, right, which is our front view, which is this one. Then we have got the top view, which is this one, and a left view, which is that one. The position of point S, which is this position point S, and point S, which we say it basically means your lowest point with regards to the point of observation. Right, instructions using scale 1:1, convert the orthographic views of the jig into a sectional isometric drawing on cutting plane AA. Right, so once we have drawn, right, we will need to make sure that we are going to come up with a sectional isometric drawing. Make S the lowest point of the drawing, show all necessary constructions, no hidden detail is required, okay? All right, like always, planning of the space that you are going to utilize is of importance. Okay, let me just shift to this. Right, we are given point S, which is that one. Right, like I said, as always, we need to start by establishing the isometric box, okay? Right, so I'm going to draw a faint line like that. Right, and another faint line going up. The other one would go to the left. These are what we refer to as our isometric axis. Right, if we check the distance from here to there, it's 120, which is seen at the top view. So we are going to measure 120. Right, basically that is our length. Then we take this one up. Then we have got the total height. The total height is going to be 80 millimeters from here to there, plus the 30, okay? So it's going to be 110. So let's measure 110 from point S. 80 plus 30 is 110. We mark that. this one. Right, and our total width is from here to there, which is 80, right? So we are going to measure 80 millimeters from here. Take this one up. Then we close to create our isometric box, like that. So we have defined our working space when we do this. Right. The next thing that we want to start with now, right, we need to start with this part, which is that one, which is also that part here. Right. So we first of all need to establish 80 millimeters from here to there. Right. If we are dealing with this isometric drawing, right, we are not going to continuously measure. Right. If the distance from here to there is 80, automatically if we draw a line at 30 degrees, that would also be equal to 80. Right. So take this one there. So we have got from here to there, that's 30, okay? Now, what it means is that if we find the center, right, from, if we project like this, we find the center from here to there, that would be 80, that would be from here to there, that's 40 millimeters, but we don't want to continuously measure like we've already said, so we're going to measure 10 millimeters, which is the thickness from here to there. Right, so this part from here to there, which is that one, is 10 millimeters. We're going to measure that. So then, at this point, we connect this one like that. Right. We can also find from here to there, that's 40 millimeters. We find that 40. Take this. Okay, so take that. But we may use this or need this one later on. Right, then we need 30, which is there already, from here to there. Right, and we need also from here to there 30. element which is not adding up. That's 10. That's 10. That's 30. That's 30, that's 30 like that. 30 and also 30. Okay. Now, once we have gotten this, we know we are supposed to come here, right? Project like that. Take this and also project like that to automatically be this, which is fine. And also here. That's the center line. We'll take it. So the distance from here to there is also equal to that. When we do this, like that. Right. So we have got this from here to there, and from here to there, from here to there. That would constitute what are our isometric square. Right. Then we connect and create a diagonal like this via the center. Right. We also can join from here to there. Right. We take our canvas right, to this point, which is also to that point as well. Right. Test like this. Then we describe an arc. So you stand on the other side, which is this corner, open to this point. You test again and see. That's perfect. Outline. Now we need a similar corner, which is like this one. So what we do basically is, right, we simply, since this is 10 millimeters, we simply do this. Right. Then we connect this one to that point, which is here. Also, sometimes you miss the points, right, which is the right point like that. Right, I'm not going to erase this one because it's basically a construction line, but it's this point that we want, not that other one. So from here to there, and also from here to there, like that. Right, once we done that, we project or from this point, which is on the diagonal, to the new diagonal like this, right? You have got this point, you have got that point. The next thing that we want also to find a new center, which is here, but such that we'll be able to stand here and open to this point to that point. But let's see if it's going to work. That is the point. Sometimes you just need to shift just a little bit in order for you to get it right. It's like this. Right. Then we stand on the diagonal that we open to this point. But you only go as far as the diagonal and you don't go beyond that. Then you blend with this first arc like that. Right, if you are accurate, you connect by drawing. You find that this should be in line with that, like that. Then you outline by connecting like this one. You know that when you do that, your constructions are correct, right? Today I want to focus on other areas which sometimes you leave out because you'll be under pressure in terms of your constructions. Right, so from here to there, right, that is 20, right, which is the same distance from here to this point. That is also 20. Right, so we can connect this point to there, like this. Okay. Right, so what we can do, we can define this now. We take this one from here to there. We also can outline from here to there. And this part as well. This. Right. These are areas which are not going to change, so we can also do the same this side. So that raised part and the top platform is now defined, right? If you check on this, we can as well take this point all the way to the bottom and also take it, but not now because it is going to be cut. But this one is not going to change. So we can as well outline this. That's not going to change. If we check with regards to the detail, the next other important thing that you would need to do, right? We have got the cutting plane here like that, right? You need to define the position of the cutting plane as well, right? It's not going to go all the way to the top part, which is that it's only going to cut this area, right? So we are going to turn here. Let me just verify if that is 40. Sometimes when you are using these drawing boards, they've got a tendency of moving. That's fine. So we come here, draw a line like this. Right. The extent of the cutting plane going this side, it's 50 millimeters. So we can either measure 50 here. That's 50. Then we take it to the isometric box like this. We take it down like that. We can also define it like that. Take it down like that. And change the direction. this side. See, we have got that. Which is that point. Right, so the cutting plane is like this, like that, like that. Take that one and you take it down. Right. Now, once you have done this, but you can now go on and define other details. But we know that from here to there, that's going to be 20 millimeters. Right, so we need that 20 millimeters from here to there. Take it this way, and we can bring this down like that. What it means, this can be outlined now. It's not going to be affected by the cutting plane, but so we can outline this from here to there. Every detail that can be defined, you can outline. Now, through the center line, here, we draw a line like that. But we know that if we look at that square base of this pyramid, right, it's square 40, but the position now is from here to there, but which is 30, so we can measure from here to there, 30 millimeters. Like this. I also want to measure from here to there, 20. Which is there. Right. Now, but also, if you look at this, right, this is slightly offset, so there it's not necessarily right in the center. Right, so we have got 17 from here to there. So first of all, we need to measure that 17 from here to there. Then we measure 40 from here right. So it's from here to there, that's 40. So the first part that we need to define is this one, which is 30. Right. Then from there, we have got our 40. Like that. Like that. So we need to shift our cutting plane slightly, right, because it is cutting through the center of the square, right? Not necessarily the center of the given part, right? So it's cutting through the center of the square. This. Measured from here to there, that's 40. What it means, we have got our point here and another point there. Let's find the midpoint. Here. It's slightly offset. It's not right in the middle of the square. It's somewhere not right in the middle of the distance from here to there, but right in the middle of the square. Right, so we need to realign our cutting plane like this. Take this one down. Should come down. And take it back. So that is our new position of our cutting plane, right? Right. So at this point, that's where we are supposed to measure. Right, at this point, that's why we are supposed to measure the square, which is square 20 millimeters, okay? So we can do this. Like that. Let's take this one. So we can take this one up. This should be 20 millimeters, and this should also be 20 millimeters like that. Right, there's nothing that would change with regards to this line from here to there, but which is from here to there and from here to there. But it would remain intact. So we can outline that. Right. And this also can be defined like this: point of cutting and also point of cutting like that. Then this is the outside. This part has been cut, and also this part has been cut like that. That is the top part. So we have got this, which is this line 10 millimeters. We've got from here to there, which is from here to there also 10 millimeters as well. But if we measure that, we'll find that it's exactly 10 millimeters. Okay, right. We know that this point is connected to that point, and this one, right, which is this point. Right, if we project this one like that, you'd find that this one would be connected to that point as well. So I'm going to connect this. Like this. Right. That's 40 millimeters. If we project like this, we would establish another 40 millimeter point here. Let me just take it all the way like that. So from here, we now have got this point. Then we need the half points in terms of our constructions. Right, okay. So that's what we have from here to there and from here to the midpoint, right? But remember, the distance from here to there should be 20, which is exactly 20, and the distance from here to there should also be 20, which is that. So the cutting plane would cut, right, like we have here, all the way down to the bottom part, right? So this can be outlined, this can be outlined, this can be outlined. It's not going to change. So let's define those lines. This part. This one as well. And this needs to be taken up like this. To this point, which is that. Perfect. This line from here, which is this one, should be connected to that. It's fine, like that. So we wait for now until we complete this detail. This detail should be connected to that. Like this. Right, and this one, it goes down. The same applies with this one, it goes down like that. Now, we also have got this information which says, right, from here to there, that's 8 millimeters. But we need this one, which is from here to there, that's 12. So we measure 12 millimeters from here to there. We have got 20. And we also have got 25 from this end. The part that is big cut is this, so we are able to draw this one and be stopped there. So we can outline again these other details, right? The point of cutting. Take this one to the cutting plane right in the middle. Right. Also take it here. Like that. Then we also take this part. Do this. Where it meets the line which is coming from the bottom there, it should go and meet that one. So it will be So we now have got from here to there and from here to there, then it goes down. But if you check with regards to this part from here to there, it is said to be 8 millimeters, but from the bottom. But what we can outline is this. And they will create a line all the way. Then we need to measure 8 millimeters. 8 millimeters from the bottom. Take it back. And take it back as well. Like that. Right. So from this point, it goes down right to this level, which is 8 millimeters. Then what we need to create an auxiliary view, right? Since we have got from here to there, right? We have got an angle of 60 degrees. So we are going to do this, create a line like that. Right, a vertical line, we measure from here to there, 17 millimeters. When we do this, then we create an angle of, but what we can do, we can measure from here to there 20 millimeters, because since it is 40, so we measure 20. Then we create this. That is our auxiliary view, right, which means from the point of cutting, right, from the center line, we need to measure from here to there, that distance, which is from here to there, but something like that. We can measure using our measuring instrument, but it's roughly 10 millimeters. We come here, measure also 10, then we project up like that. Now, this point is connected to there, and this one is connected to this one. Do this. Then we take this one. We do this. Right. So we have created an angle, right, based on the auxiliary view. So this is our auxiliary view, right? And that angle that we have created and the distance that has been defined here is the same distance from the point of cutting. This is our cutting line, right? So we take that distance, take it up, connect it to this end, and so forth. So now we are in a position to outline quite a number of lines. Right, we can outline this. Right, we can also outline this. There's nothing that would stop us from outlining this now. Right, and also outline from here to there. You can make use of a set screen for outline also this vertical line. Let's take this and also you need to have a system in terms of defining the lines. If you are working with vertical lines, you continue with those vertical lines up until you are done, right? Then you start with another set of lines. So I'm going to outline from here to there, right? And also from here to there. Right. Then we define that, we outline this, we outline that. This can be defined like this. Right. So that is the platform, which is this one. Okay. So what we have now is from here to there to there, right? And it's a slot, which means it goes down like that. Also, let's go back here. We can define this. This is cut from here, which is that point, and also to this center line at the base. We also do the same. We can also outline this part. Also that we should have started with this. But remember, when you outline, expose the first part. Do this. This is a corner, which means we should be able to draw an isometric line. But remember, this height from here to there, which is from here to there, that's the 12 millimeters. Then we have got that level, which is this level here. Now, we now have got this part of the detail. So when we hatch, maybe we should just hatch now. But what you do is check and try different angles. I think this one would work. If we do that, it will also work. So I'm going to hatch. So this is the part that has been cut on the left-hand side. So when we want the one on the right-hand side, first of all, just align with one, then we can just do this. Then we go. Actually, these are adjacent, so it's different direction. one cutting plane, but when we are dealing with isometrics in terms of sections, you change direction like that. Right, okay. It wasn't supposed to show that part, but basically that's how we represent the part that has been cut. Now we can even go back now. We can go back. If we check with regards to this line, we have got this corner which we took it down, which is the same as that one, but partly hidden here, but it can also be projected to this one. But there's nothing that is going to change with regards to that. So we can as well define this partly upscaled. See that. So we now have got the detail of this part, okay? But as you can see, there's an angle which is there, right? So we cannot, what we know is that the horizontal distance from here to there, that's 50. But we don't know the height from here to there, since it's not going all the way like that. So what you need to create an auxiliary view. So we can do this. An auxiliary view, take this. That was this was the one that we wanted. We measure 50, which is the 50, which is the horizontal, right? Then we draw at 30 degrees, 30 plus, right? 30 plus 90, we find that we have got 120 degrees, which is that, okay? Right. So the distance that we want is this one here. So I can just outline this. Create this. But we want this distance, which we can say that's distance A. Okay, remember, this is also our auxiliary, the auxiliary view. Right. So if we measure from the base to that point, 40 millimeters. Right, if we measure 40, like that, we get to this point. Right, take this. Bring down like that. Then stretch it like this. Stretch it like that. We know that we are able to find 50 millimeters. So we measure 50. We mark a point here. That's 50. Then we project it backwards like that. We take this one up. Take this one up like that. Once we have taken that one up, we now take this distance A, okay? That we can measure, or you can make use of it. The canvas, which is about 29 millimeters. So come here, measure 29. we mark this. There we go. We have got this point. So this point is now connected to there, and in turn it is also connected there. So we're going to do this. The first part is connected to there. It's also connected to this. Like that. Then it creates an angle of 90 plus 30 degrees. Like that. So from here to there, that's 50. Let's just verify. It's fine. So when we are looking from the top there, but we'll be able to see the distance from here to there, that's 50. So we can now outline this part. This is a typical example of what we refer to as a non-isometric line. We connect this one to them. Take this one to this point. We start with this. Always expose what you have done. But sometimes you may end up drawing a line at a wrong position because you are not able to see and relate with what you have done. Like this. We take this one down. So that is the part which is here, right? Of course, you'll find that in terms of isometrics, certain details might be lost, right? In terms, this would appear much, but because it's isometric projection, right? You'll find that the distance in terms of the height from here to there, which is much higher than that one, would appear distorted, okay? But otherwise, that is how it would be represented. Right. The next thing that we want to look at, that if we check that on this part, which is that slot here, okay, right, we should be able to draw that. And so that is the center line. If I want to get another center line, I can just connect this one from here to there. It's basically what we have, which is this point here, because that is the center line. So we can also do this. Okay. Right, it says 40 square. So I'm going to measure 20 and 20. $20 this side and 20 millimeters that side. Then connect. We'll go to this. Here, thanks. Point, you put that point. This one is already there. Okay, it's the point that we want. So that is the square. But if we want the other one from here to there, automatically is 20, right? From here to there, right? Because the thickness from here to there, but you can also verify, you can take this one here, right? And take it backwards, like that. You'll find that it's one and the same thing, right? So you would need now to outline this. That's 40. You also need to outline from here to there. That's part of the 40. And here. There you go. That is the opening that we want, okay? But if you do this in an exam setup, what you find that you would have gotten all your marks in terms of the isometric drawing. So let's hope you enjoyed this lesson, and there are certain things that we were able to iron out in terms of your understanding of isometrics, but how to approach an isometric drawing and how to present that isometric drawing as well, right? And more importantly, you should be able to do this on your own so that you understand the application part of it. Thank you and good night.